Hey guys, and welcome back. So in the previous nugget, we had just walked through the Linux boot process, and we learned that the eventual end state ended up with something called systemd. Now systemd is a new implementation, or a more modern implementation, of something called SysVinit. Now SysVinit is something we have to learn and understand because we are taking the LPIC 1 examination and it is a tested topic. So whilst this might just seem like more of a history lesson, understand that systemd does have backwards compatibility with SysVinit, so there still is quite a lot of relevance here. So let's talk a little bit about SysVinit. So here is one of the key things to understand with SysVinit systems, is that the very first process that's going to be run is something called init. This is the daemon whereby all other processes are spawned from. So right now on my modern system, if I happen to type the command pstree, this is going to show me a tree of all my processes. At the very top, because I'm using a modern system, we see that the root process is systemd. In the case of SysVinit systems, what you would see here is the word init. Now SysVinit will try to find the init program within the sbin directory. So we go into sbin. If we do an ls, we can actually see this program here init. So understand that this would be the location in older systems where we would actually have this process. So it would be in sbin /init. And like I say, this is what would be used to start all the processes and all the services. Now, the key thing to note here is that when we are using SysVinit, the processes are built in a linear fashion. So that means that init will start, and then we can kick off the next process. Let's just call this process X, and then kick off the next process, which could be process Y, so on and so forth until everything has started. Naturally, because of this sequential nature, this is ultimately quite a slow solution. And this is actually one of the reasons why SysVinit was superseded with other solutions. Now, in order to be able to find the correct processes and in which order to run these processes, init will find these in two different directories depending on the type of operating system you're using. And this is quite an important subject relating to the examination, so try to pay attention. So if we have a Debian-based system, so something like, say, a Ubuntu machine or a Xubuntu or Lubuntu machine or a plain old Debian machine, the location is going to be in /etc and then in something called init. However, this is for Debian-based systems. If we happen to have a Red Hat-based system, the location is going to be /etc /rc.d. Now within these type of directories, for systems that are using init, we'll see files such as rc0.d or things like rc1.d. Now, these numbers actually relate to something called run levels, and this is a concept we will revisit a little bit later on within this skill when we talk about run levels, but ultimately, run levels are a concept relating to SysVinit that just define the operating state of the actual system itself. So run level 0 in this case, so rc0.d would correlate to run level 0. This would denote the system being shut down. Whereas, when it comes to rc1.d, this would relate to the run level known as single user mode. And again, don't exactly worry about this quite just yet. We'll get to talk about run levels a little bit later on. But understand that init is going to look in these two different directories depending on whether you have a Debian-based system or a Red Hat-based system. Now, another thing to note is that when you happen to navigate into one of these directories, such as rc1.d, you will see a whole bunch of different symlinks. Now, if those symlinks begin with the letter K, they relate to killing processes, i.e. stopping processes. However, if you happen to see symlinks beginning with S, you can guess where this is going. These relate to starting processes. So really try to conceptualize that in your head. In these old systems, SysVinit, init is going to look in etc init.d for Debian systems and etc rc.d for Red Hat based systems. Within these folders, let's say we just have the Debian based system and focus on init.d. Within init.d, we will see further directories relating to what are called run levels. So we'll have files such as rc0 rc.d, and other things like rc5.d. Again, we'll talk about run levels very soon. These numbers correlate to these run levels, but if we go into these directories themselves, say for example this one right here, we did a cd rc5.d, inside of here we would see a whole bunch of symlinks beginning with K for killing processes and S for starting processes. And ultimately, these symlinks we're talking about, they point to scripts which actually carry out these tasks of killing processes or starting up processes. And similarly, these symlinks here, they will also have numerical values, so it won't just start with an S or start with a K. It'll also have a number after it. So it might end up saying something like, say, K, let's say 12, engine X. The way we can translate this is we understand this script is going to kill something. It's at number 12, so this is the order of operations, meaning that K1 will run before it, K2 will also run before it, all the way up to K11, and then when it gets to K12, this is going to be the script that is executed. And the remaining part of the name gives us a kind of clue as to what this is going to do. In this case here, this would ultimately stop an engine X process, which is a web server. So what I'll do right now is I'll just quickly install an Apache web server. Don't worry about how to do this. We'll talk about this later on within this course. I'm just going to type this command, sudo apt install apache 2. I'll type in my password. I'll say yes, enter. And what I can actually do, I can force SysInit to start or stop this service if I so choose. So what I could do is I could use initd by saying etc, init.d, and I'll go into Apache 2, which should now be here. And I could just start this service by using the command start. If I hit enter, so to start the service, I need to type in my password. Authentication is complete. The web server would be up and running. If I wanted to stop the service via initd, well, I could just change this command here to stop. If I hit enter, again type in the password, and we can stop the service. So that is us for our brief visit towards SysVinit. Key takeaway points is to really try to remember the location of where init is actually going to look to see which processes have to be started. /etc /initd on Debian systems, as well as /etc /rc.d for our Red Hat based systems. Understand that the init daemon, this is going to be the mother of all processes from which all other processes come from. And also remember that SysVinit really had a type of performance limitation. That was, processes were spawned sequentially in a linear fashion, and was one of the driving factors for it to be effectively usurped and replaced by better systems. So what about these replacements for SysVinit? Well, there actually are two that we want to talk about for the purposes of the examination. We have heard of systemd, but there actually was one before that that didn't last quite too long, but again, it's important for the examination. That is one called Upstart. And this is what we're going to be talking about in the very next nugget. So I hope this has been informative for you, and I'd like to thank you for viewing.